All right, then I'll get started. Hey everyone, I'm Nicholas. I'll be talking to you about Data Science Club today. I am an exec on Data Science Club, and I'm also a 3B computer science and stats student. Here on the slide, I have some information that may be useful to you before we start. So first is the bit.ly link for the slide deck, and so you can follow along, and also so you don't have to copy links down, you can just click them directly. I also have my email here and my Twitter handle. You can reach out, ask me any questions. I'm very happy to help out. So before we start, I will be monitoring the Q&A and the chat throughout the presentation, so feel free to ask questions live. I can answer them in real time. And yeah, also let me know if my audio lags or video lags, or I need to repeat something, go back to the slides. Like, we have tons of time, and so I can definitely take my time to answer questions. And with that, we can get started. Cool. So just an overview of what we'll be talking about today. The first thing is we'll be discussing Data Science Club. We'll be talking about what it is, why you should join, how you can get involved, etc. Then afterward, for a majority of the presentation, we'll be talking more about what exactly data science is. So we'll kind of cover three main definitions, which is like data science, machine learning, and artificial intelligence. And then we'll talk more about what various career options are in this field. And so this will pertain to both full-time opportunities as well as internship opportunities that you guys can look into during your time at Waterloo. And finally, we'll close off talking about how you can steer your education at Waterloo for a career in data science. And so this will talk more about clubs and societies you can get involved in, as well as courses and majors and how it all fits into the picture. And with that, we will get started. So what is Data Science Club? So here's our mission, and it's that we want to build a community for those who want to learn and talk about data science at the University of Waterloo. And so we achieve this through various events and online initiatives. This includes co-op panels, mock interviews, and resume critiques to help people get co-ops in the data science area. We also have lectures, talks, and workshops, both that involved in theory and the practical side, and so people can learn about data science. And these are targeted towards both absolute beginners as well as people who are more advanced. We also have reading groups, which are targeted towards people who are more advanced, who want to learn more about the theory behind data science, machine learning, et cetera, on a more regular basis. And we also have industry talks and professor talks, which bring in people in the industry who work on data science or professors whose research is in the area, so they can talk more about it. So you have the opportunity to learn a little bit more about how this actually plays out in the real world, and tons more. We, of course, hold lots of social events. We have beginning of term, end of term events. We try to host like online games nights, especially during online terms. So it's a ton of fun. It's definitely a great thing to join. So the big question is, how can you get involved? So again, firstly, like, you don't have to copy any of these links because the slide deck is right here. But here are some 4 important things you can do. The first one is a member signup. So for the member signup, we just ask you for your email, your name, and that's basically it. And this will keep you up to date on all the events that Data Science Club hosts via email. You can also reach out to us via our Facebook page or our email, and we're pretty responsive, and we can definitely help out with any questions you have there. And finally, something a little bit newer that we do is the Discord. The Discord is a place where people can congregate and chat about various things related to data science, whether it's projects they're doing, courses they're having trouble with, opportunities that they're looking for. It's a great place to meet more people and kind of have some online discussion about what's going on. And here are also 3 other links. And so on YouTube, you can check out some of our past workshops and lectures. They're all recorded pretty well, so it's a great experience watching them. And we also have our website and our Twitter, which are less active right now, but we're hoping to get a little bit more active. So I guess before I continue on, does anyone have any questions about things I've said so far? Anything about Data Science Club? You can type it in the chat or the QA function. I see both. Cool, it looks like we don't have any questions, so I'll get going if I'm here. Well, so now we're kind of going on to the meat of this workshop presentation, where we'll be talking more about what exactly data science is, why you should care, and to just give you more information in case you're interested in pursuing this path in university. So here is a copy and paste definition from the web, which says essentially that data science is an interdisciplinary field that uses scientific methods, processes, and algorithms, and systems to extract knowledge and insights from many structural and unstructured data. That is a long sentence. And data science is related to data mining, machine learning, and big data. Essentially, the key aspect of data science is the ability to draw insight and knowledge from vast amounts of data, whether it's structured data, like, for example, tabular data sets that you may be familiar with, or even unstructured data. So you might imagine raw text or images that need to be processed. And of course, this definition is from Wikipedia. So I guess to better illustrate what exactly data science is, I can give you a few examples, but overall, it's very broad and, to be honest, quite ambiguously defined right now. So some examples of data science include like visualizing voter patterns across the country, or possibly A/B testing a new product feature with users. So if you have some product and you want to see if a feature is useful to users, it's very common to have an A/B test where one group, the control group, doesn't get the feature and another group does get the feature, and you see how their behavior interactions change. Netflix's video recommendation engine is a common and very popular application of data science. Identifying fraudulent credit card transactions or fraud in general, whether it be credit cards, insurance, etc. The matching and routing algorithms for Uber's drivers is heavily based on data science and the past data they have to optimize these algorithms for the future. Determining pricing for insurance. You can think of, in the case of self-driving cars, identifying objects on the road and predicting where they'll be in the future. You can think of facial recognition software, generating fake images for good or malicious. And basically everything you use in your day-to-day life has some aspect of data science in it. So nowadays, increasingly, companies are using the feedback loop and data from their consumers in order to optimize their products to make them much better suited for their end consumer. And so basically everything improved in a cycle through the use of data science, whether it's very simple analysis techniques to very complex machine learning models. So before there is a question, Q&A, I almost missed. What are different positions open to first-year students so we can contribute to the club efficiently? That's a great question. Let me restate that. So the question is, what different positions are open so students can contribute efficiently? So there are basically two main kinds of members. There's a normal member, and then there is an exec member. So a normal member, you sign up through the sign-up form that I posted, and basically have the opportunity to attend these events. You can stay in the loop. You can interact with others through the Discord or through Facebook. And basically, as a member, your main contributions are like through the interactions with other club members. There are also opportunities to become an executive of the club, and there are many roles that are available. And so to give you some examples, there's a VP of Education, which hosts various workshops and lectures that you may see on the YouTube channel. There's VPs of Planning and Logistics, which kind of organize the various events. There's VPs of Outreach, which basically deal with communicating with other clubs, collaborating with other clubs, as well as communicating with companies and professors to get external talks or to get sponsorships, etc. And so I guess if you just sign up through the member sign up that I showed a little bit earlier, you can definitely see, messing up my slide. If you're signing up as a member, you'll definitely be in the loop about more opportunities that come up. But I guess the first step is to just sign up to be a member, which is on this slide deck earlier. Thanks for the question. Cool. Okay, I'll keep going. Now, what is machine learning? And of course, machine learning is such a buzzword that I have to type it out with the spaces in the title, or else it doesn't have the same vibe. So the definition I found online kind of goes as follows. Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. And so the basic idea is, given that you have a lot of data, you are able to train a model to do what you want it to do. So conventionally, when you have some computer program, your role is to very precisely outline the operations it must perform in order to accomplish some task. In machine learning, the idea is kind of flipped. You have many examples of how to accomplish a task, and it's up to the computer's, many examples of like the end result of the task being accomplished, and the computer's job is to kind of figure out how to do so. And so examples of this could be in like computer vision, it's very common. Conventionally, in the past, programmers would have to code in how an algorithm would identify edges in an image, identify various features, and finally make a prediction. Whereas in modern machine learning, we often have image classification pairs, for example, whether an image is a cat or a dog. And by having many thousands of these examples, we're able to train these models to do this for us. So for some examples of machine learning, you may notice that a big portion of this list was also on my list for data science. And that's because I would consider machine learning a subset of data science. It's really driven by many statistical and computer science fundamentals, which are completely in overlap with data science. So there's another question. Yeah, no worries. Don't worry at all for driving off topic. This is what the information session is for. Yeah, so the exec positions are open to first years. Typically, for a role like VP of Education, we would expect someone with more data science experience. But basically, for all the other positions, like the logistics positions, outreach, et cetera, we don't expect much data science knowledge. We just want you to be like kind of committed and interested and be willing to contribute. And so, yeah, first years are totally welcome to apply. And once you sign up to be a normal member, we'll definitely follow up with executive applications, which should open pretty soon, probably next week. But yeah, thanks for the question. There's another question here about what the difference between BMath and BCS data science is. That's a good one. And I'm going to talk more about that at the end of the presentation when I talk about the various majors and courses at Waterloo. But thanks for the question. Cool. We'll get back to some of the overall definitions. And so the final one I wanted to talk about was artificial intelligence. And I kind of wanted to describe this in this Venn diagram where we kind of had data science in one side, artificial intelligence in another, and they have some intersecting, like overlapping area. And a subset of that overlapping area is machine learning that I just talked about. So artificial intelligence broadly is having a computer mimic intelligent human behavior. And so you can imagine that a big portion of this could be through machine learning, but there are also many like other techniques to have computers emulate humans. And many of these techniques are founded in like robotics and control theory. And so not all artificial intelligence is related to data science and machine learning, but there's a lot of overlap between the two fields. I won't go into this too much because our club's focus is a lot more on data science and machine learning, which overlaps with the artificial intelligence, but is not necessarily 100% focused on that. Cool. So before I move on to kind of the career options in this field, does anyone have questions about the things I've said so far? Lovely. Okay, cool. We'll keep it going. So for the next, I guess the majority of this presentation, I'll be talking about various career options in this field and what these various careers entail and how you can kind of get a taste of these on your own time. And so I kind of categorize it into five broad categories, being data analyst, data scientist, machine learning / research / software engineer, a data engineer / architect / consultant, and finally a research scientist. So just a quick disclaimer, these are my categorizations, and I find these to be a very useful mental model to think about the field, but they're not necessarily consistent among all companies or among anyone you'll talk to. Many companies will name positions in different ways. So for example, many times a software engineering position may be maybe like very data science focused, or a data science position may be like very data engineering focused. And so it's very important to kind of clarify that through the job description and through the interview process. But these are just high level categorizations for you guys to get a good understanding. Cool. So we'll start off with data scientist, data analyst. So what does a data analyst do? I would love some participation. So if you guys could maybe send a message in the chat describing in like one sentence what you would think a data analyst would do. Maybe it's obvious from the name, but I'm sure I'll see some answers that are like accurate, but not so obvious. Oh, thanks. I appreciate that comment in the Q&A. Okay, it looks like our chat is empty or I'm not seeing messages, but that's okay. We'll just get it rolling here. So something happening here. Oh, gather and find data trends and patterns. Thank you. Yeah, but essentially it's gathering, organizing, visualizing, and analyzing data to make conclusions to drive decision making. That's a mouthful, but essentially a data analyst's role is to understand what data exists within the organization, to understand what data the organization needs, to analyze this data and present this data to other people in the organization. So whether it be other people on their team, people on neighboring teams, or executives, etc. And ultimately, the most important thing is they're able to drive decision making within the company. They want to provide some insight that helps people make decisions to improve the state of the organization or company. And so you may be wondering, that's like a super broad definition. And so this could range anywhere from analyzing profits in order to understand where to allocate resources, to performing A/B tests on products to understand which features are useful, which features are not. It could be identifying fraudulent information in customers. It could be analyzing supply chain to understand where we need to buy more versus buy less for the stocks that you have. So there's a very wide range of things that data analysts can work on. And so this is kind of reflected in what kind of companies people can work in. And really, a data analyst works at all sorts of companies. Like nowadays, literally every company is collecting data, needs data to improve their product, and therefore they need data analysts. And so there is no shortage of careers in data analysis. In terms of tools and skills, I'll give you a brief overview of some of the concrete tools that people use, but I don't expect you to know these or remember these, but this is just there as a reference so you can kind of get familiar with these terms. And so some popular languages include Python, R, and SQL. So Python is like a general purpose programming language. R is designed for statistical analysis, and SQL is designed to manage tabular data. And so these are three very popular languages in the industry to manipulate data, analyze data, and present data. For data science, do we need to know programming languages or anything else? If yes, then what? Yeah, I think the three languages I list here, Python, R, and SQL, and I think with an emphasis on Python and SQL, are great things to learn when you're starting out in data science. They are pretty much ubiquitous in the industry, and you will not go wrong by getting to know those languages. Yeah, thanks for the question. In terms of software, Excel and other data modeling tools are very common and very useful. And of course, like visualization tools are extremely helpful. So here I list 4 of them. You probably don't recognize them. Some of them are libraries, others are tools. But again, this is something you can definitely search up later. And in terms of skills, overall, data analyst is very important to have both statistical skills and communication skills. As an analyst, half your role is the whole data part of the thing. So collecting, analyzing, visualizing data. But really, the other half of your job is communicating these results to others in your organization or your company. So it's very critical to have clear communication and presentation skills. And how can I get a taste? And so I'm sure a majority of you are co-op students, and even if not, I'm sure the rest of you may be interested in internships in your summers through university. And so it's very important to get a taste of some of these roles when you're applying. And so you have a stronger skill set, you have a stronger portfolio when you're applying, and so you know what you're getting yourself into. And so you can apply to things that you know you'll learn lots in and you know that you may enjoy, so you can try it out. And my biggest suggestion to learn data analysis tool techniques is Kaggle.com. So Kaggle is a website now owned by Google that essentially hosts data sets and data science competitions. I would recommend looking at the data sets on Kaggle, and there's a ton of useful information about these data sets. There are analyses that other people have performed on these data sets. They're called kernels, and basically they're like various write-ups and visualizations associated with the data set. And it's a great way to just absorb what other people have done, try your own analysis, post it out there for the world to see. And overall, it's a really great resource. And recently, they've been publishing more courses and tutorials about how to actually analyze data. And so I would highly recommend checking out Kaggle.com if you're interested in data analysis. Cool. I'm going to go a little bit. Oh, so maybe before I continue, any questions about like a data analyst type role? Cool. I'll just keep going. I'm going to go a little bit out of order here. Before I talk about a data scientist role, I'm going to talk about the engineering aspect. And so this in particular is talking about a machine learning / research / software engineer. So what do you do? So a software engineer is a very broad term, and there's a lot of things that they work on. I'm going to talk specifically about how this pertains to data science. And so this is more commonly called machine learning engineer, but a lot of companies post these roles as just software engineer, and you kind of got to fish it out of the interview or the description to really see what's going on. So really, a machine learning engineer's role is to create and deploy these models into production. And so what do I mean by create and deploy? So for example, for the video recommendation algorithm that Netflix uses, maybe a data scientist or a team of data scientists and engineers have created this algorithm, but it's critical for the company to actually put this algorithm out there to serve it to users so they can actually get recommendations. And that's a big part of what a machine learning engineer does. They'll be optimizing these data machine learning pipelines to make sure they're fast, to make sure they're reliable and usable for their customers and others at their company. And finally, they'll be creating infrastructure and tooling in order to facilitate machine learning. So often, if a company has both engineers and data scientists and analysts, you need infrastructure in order to access the data. You need infrastructure to train models and deploy models. And so these engineers are working on all of these things. And so you may wonder what kind of companies would employ these kind of engineers. And primarily, it's companies that use machine learning in their products. So unlike kind of a data analyst role, a machine learning engineer's role is more closely tied to the product and how closely tied to the product in the sense that the model may actually be used in the product. And so companies that use machine learning in their products, which nowadays is many, many tech companies and others, will probably need machine learning engineers. And also technology companies that incorporate data science into their work internally. And so even if the product is not related to machine learning, they may use machine learning and data analysis to understand features of their product, et cetera, for example, A/B testing. And so these companies would also need engineers to maintain these systems. Good question, Jacob. I will actually address that once I kind of done my book. And finally, large companies that do machine learning research. And so in kind of the header, I included research engineer, and I haven't really talked about that too much yet. But essentially, a lot of companies do kind of fundamental machine learning research, which I'll actually talk about in more detail in the coming slides. But large companies that do research will often also have research engineers. In terms of tools and skills, it's very similar to a common software engineer. You need to have strong coding abilities, strong engineering abilities, et cetera. Could you make this presentation available to everyone? Yeah, I can. So this link here will take you to the presentation, which I just sent in the chat. Thanks for the question. So in addition to these skills that a software engineer has, statistics are extremely important for a machine learning engineer to understand. In order to maintain these models in production, to understand how well they're doing, to understand how we can improve them. Like, for example, your customer base will evolve over time. Your models similarly have to evolve over time. So it's like imperative to understand statistics in order to be an effective machine learning engineer. And below, I just listed some tools and languages that machine learning engineers commonly use. Again, I don't expect you to be familiar with these, but these are just great references for you to search up later. And of course, cloud infrastructure skills. Increasingly, these machine learning models and these pipelines are in the cloud. They're no longer in some server in some back room. They're instead hosted by these cloud services like Google Cloud and Amazon Web Services. So in the modern day and age, it's very imperative for a machine learning engineer to understand how these systems work so they can leverage them effectively. And in terms of getting a taste, I think the main way you can do so is to work on kind of engineering related or development related side projects on your own. And so in particular, this could be deploying a machine learning project to a website or an application. So if you're interested in data science, you may do a project where you identify whether an image has a cat or a dog. And that's a pretty interesting project that you can do on your own. But to take it one step further and to really add that engineering touch, you may want to put it on a website or put it into an app, just so where people can actually use it and where you'll have to maintain it. And so that's a great step you can take to improve your skills to become more of an engineer. And one thing that's a little bit less considered or fewer people know about is research assistant roles at UWaterloo. So as a younger undergrad, you may not have the theoretical knowledge to contribute theoretically to the research a professor or PhD student is doing, but you definitely have some basic coding skills that you could definitely help them out with. So I think doing these research assistantship roles at Waterloo is a great way to get your hands dirty with some machine learning and build some of those skills that are relevant to a machine learning engineer. And finally, design teams at Waterloo are a great way to get involved in machine learning engineering. There are many design teams. So maybe first I'll talk about what a design team is. A design team at Waterloo is essentially a group of students who are working towards some project that's kind of like endorsed by the faculty. And so by endorsed, it's like you don't have to worry about the endorsed part. It's basically meaning that they're officially kind of recognized. But the key aspect is they're working towards something. One example is the autonomous design team. The autonomous design team works on a self-driving car that they're going to use to compete in GM's auto drive competition. And so this is a great design team to join to learn more about machine learning because they use a lot of computer vision techniques to identify objects on the road, to identify lane markings, to plan the car behavior. And so even as a freshman, you can definitely join these teams, get exposure, and get experience. That's very helpful. It's going to be very helpful for you. So Jacob has a question about how many machine learning engineer jobs are available on the market and what sort of requirements do these positions have? So that's an excellent question. I think nowadays there are a ton of roles. I don't really have a quantitative number for you, but the number is growing all the time. And in terms of requirements for these positions, it really varies based on the company and the precise role. So some of these roles expect like an undergrad. So this is like full-time conversation, but some of them expect like an undergraduate degree. Some of the more advanced positions, especially in like research engineering, may expect a master's or a PhD. But often these master's PhD roles, the education can be substituted by experience. And so there's a really wide range of experience that's acceptable. And I think more and more companies are recognizing that education is not the only stamp that would give you the certifications to do these roles. And so, yeah, I hope that answers your question. Oh, okay. So Ishan asks, how much experience are we expected to have in coding/data science before joining the club? That's a great question. A majority of our joining members have little to no experience in data science. They've just heard of the term and they're just really interested in learning more. And so often we have both events for beginners, intermediates, and advanced members. And all of our like very beginner workshops are also posted on YouTube, and so people can kind of get up to speed. And so yeah, we have no expectations about how much knowledge you should have. You should just really come with an interest to learn more and talk to others. Yeah, thanks for the question. Cool, I will move on. Next, I'll be talking about a data scientist. So data science, what does a data scientist do? The way I think of a data scientist is kind of halfway between a machine learning engineer and a data analyst, plus a little bit more. And so they have the engineering skills they need in order to create and productionize these models. And they also do the role of a data analyst where they analyze data to drive decisions in these companies. And this role varies a lot between companies and industries, et cetera. It's like very variable. This term is very poorly defined right now. So yeah, this is the same sentence as I had for data analysts. It's gather, organize, visualize data. Oh, there's a Sunny Kim says there's a question in the chat box. Oh, okay, it's been answered verbally. Cool. Just want to make sure I don't miss anything. And so a data scientist also has to design models to make inferences or predictions about complex data. This is one distinction I find between a data scientist and a data analyst, at least in my terminology. Of course, a lot of companies mix the jargon more. But I find data scientist roles are dealing more with complex, unstructured data, such as raw text or images that a data analyst may not be dealing with. And so naturally, this requires a little bit more skill in some cases and different sets of qualifications. And finally, it's important that a data scientist is able to evaluate and improve models in production. So this is something I touched on for a machine learning engineer as well, but it's very critical that data scientists can understand how their customers and their population is changing in order to adapt and improve these models over time and to really validate that they're working well. So what kind of companies employ data scientists? All sorts of companies, particularly those with a focus on data and particularly those with a focus on complex, unstructured data. And so the data scientist has many different names in many different industries. Like some industries will just call them data analysts. Some will label them as engineers. Some, for example, in insurance, it's very common to label data scientists as in like the advanced analytics division. And so all sorts of companies have these roles, but just sometimes under different names. So in terms of skills and tool sets, it's really a mix between what's needed by the machine learning engineers as well as data analysts. It's very important for data scientists to be able to wear both hats and to understand both sides of that equation. And in terms of getting a taste, I think Kaggle is a wonderful resource to learn more and to experience data science for yourself. Before I mentioned Kaggle hosts data sets, they also host these data science competitions. Essentially, companies post these data sets with some prediction objective. And it's your goal to create a model that's able to predict this objective very well. And basically, you can do this in teams, you can do this individually, and the best teams, there's often some sort of prize. But really, the real prize is like the experience and the knowledge you gain through it. And it also shows very well on your resume for applications in the future. That's kind of an overview of what a data scientist is. Any questions about that slide? Cool. Okay, I'll keep it going. The next one is a data engineer slash architect slash consultant. So the focus of a data engineer is actually quite different from the first three. And so this is someone who's more concerned about the data aspect and in terms of designing, implementing, and maintaining these data collection, storage, and serving systems. And so for any company to be effective in the data that they use for their product or internally, they need to make sure that their data collection and storage is efficient, effective, and reliable. And so all sorts of companies need data engineers, but again, particularly those with a focus on data. But again, this spans across tons of industries, not just in tech. Because again, as I mentioned, like all sorts of companies nowadays, in order to stay competitive, are doing more and more with the data that they have. So I've just listed some tools and frameworks that are commonly used in data engineering. Again, I don't expect you to know these, but they will likely appear on job applications that you see. But once again, like general engineering ability is very key for this role. And it's quite different from data analysis in that way. Yep. Once again, similar thing that I mentioned before. This is the one thing I'm not so sure about. So for the previous three roles, I talked about how you can kind of get a taste outside of like a co-op position or outside of a full-time position, how you can do so on your own time. For data engineering, by definition, it's very tough to get this experience on your own because it relies on the challenges of having so much data at a company, unstructured data, needing to optimize these pipelines for usage by others at the company. And so I would say it's challenging to get this experience on your own. And if anyone has ideas, I would love to hear them so I can update this presentation for the future. Are there any particular courses at Waterloo you would consider to be more important or relevant to data science and machine learning? Question by Jacob. Great question. This is something I'll address in like 3 slides. Yeah, but hold that thought. Thanks for asking. The final thing I'm going to talk about is the machine learning research scientist. And so you may all be familiar with a research scientist. It's someone who like deeply studies newer existing problems or solutions to newer existing problems. For machine learning research scientists, this is particularly in the area of statistics and computer science, which is kind of what machine learning and data science is composed of. And so for a research scientist, this work you may imagine to be very theoretical or very hands-off, but really often it's very applied. It can be applied or theoretical, and it can be very closely tied to industry as well. Many industries have like these labs with research scientists doing very applied research. So primarily large companies and universities will have research scientists. So at universities, of course, you have your PhDs, your postdocs, your professors who are doing research. But often these larger tech companies with enough funding and I guess profits to actually fund their research lab will do research, both to improve their products. So this is like a very applied research scientist, or it could be fundamental research that like just pushes the field forward that doesn't necessarily improve the company's products. So some key examples of this are Google, Facebook, and Microsoft. These three have these large industry labs that do research that don't necessarily help the company's profits or help the company's products, but really just move the field forward. And I think that's a great thing. And yeah. So in terms of tools and skills, it varies a lot, but I think the key comes down to research skills, whether it's communication, analytical thinking, et cetera. and the specific skills you need are really dependent on your precise area of research. Also, often for these research scientist roles, a PhD is like mandatory. It is very, because a PhD you can think of as essentially training for a research role. And so many of these companies will only hire research scientists who have completed a PhD. And universities will only accept people who are either doing or have their PhDs. I think there are cases where you can circumvent this requirement and just kind of have experience in order to get into this area. But I think it's a lot more challenging than for the other roles that I mentioned. And undergraduate research assistantships are a great way to get a taste of this while you're in school. Of course, you'll be working with a professor, and so this is a great way to get your hands on with experience. And you'd be surprised at how little knowledge you need to have to really get started, because professors are very good at breaking up their projects into bite-sized chunks that an undergraduate can learn from, and they're very happy to help out. And so it's a great way to get started. So I guess before I talk about the courses and Waterloo a little bit more, are there any questions anyone has about any of the things I've talked about so far? Do I have any plans for how to run the club virtually? That's a great question. So some things will change. So one thing that we've been doing is instead of having in-person workshops and lectures, we do them online over Zoom. And this has been working relatively well. It's definitely not perfect. I know a lot of our lecturers strongly prefer having an in-person environment, but this works great. I think you're still delivering content and still getting some interaction. To replace some of the social events that we do, such as the beginning of term, end of term events, we have some online games nights. And so this is like playing board games with other club members, hopefully to spur some interaction. And of course, our Discord is also very active. Well, I wouldn't say it's very active, but we're trying to get it to be more active. And so people can definitely interact with others over Discord. Apart from that, we're definitely open to suggestions and ideas about how to run the club more effectively virtually, because yeah, this is like a first for all of us. Thanks for the question. For data scientist jobs, will an undergraduate degree be enough? That's a great question. So I think a couple of years ago, I would have said no, because a lot of these roles require a master's. But increasingly nowadays, these data scientist roles are opening up to people with an undergraduate degree. And the quality of these roles are no less than the quality of the roles that were available to master's students. And this is for a couple of reasons. The first thing is there's been a huge influx in resources to learn data science without a university education. And so companies are recognizing that, and in order to get the best talent, they're opening up these roles to more people. And so as long as you can be an effective data scientist with the skills that they need and the projects to prove that you really can do what you claim to do, then I think an undergraduate degree is enough. And you'll especially see that through the co-op positions that are available. Like these co-ops are now available to undergrads, whereas previously they were only available to master's students. So the field is definitely opening up. I think an undergraduate degree is enough, but again, it may not be enough for more theoretical roles. So especially roles that are more advanced, especially in research and development and et cetera. In those kind of roles, then more advanced degrees start becoming more necessary. I hope that answers your question, Sreejan. Any other questions? Cool, I will keep going. So next I'll kind of talk about how you can steer your education at Waterloo for a career in data science. And so I'll kind of break this up into two parts where I'll first talk about the various majors and courses available at Waterloo, as well as other extracurricular activities. So in my view, the most relevant majors to a data science career is computer science, statistics, and data science. These are three available majors, and they are all, I would say, all important. One thing to note is that computer science and stats, well, actually, I'll explain this for later, but yeah, all three of those majors are the most relevant. I do kind of want to talk a little bit about what exactly the data science major is, because there is some confusion about that. And so first I'll explain a couple of things. The first thing is the difference between a double major and a joint major. And so a double major is a major where you complete all the requirements for two separate majors. So for example, personally, I'm a computer science and statistics double major. I'm completing all the requirements for both majors. It's possible to mix and match like basically any two majors in the math faculty, and you can do a double major that way. A joint major is basically a special subset of two different majors that allows you to do like, a joint major is considered to be like one major that's composed of two parts. So for example, you can do a joint pure math and stats major, for example, if you wanted to, or like, a pure math and CS joint major. And so this is like a little bit easier than a double major, but it's considered one major with two parts. The data science major is really just joint computer science and statistics that's been rebranded. So you can actually no longer do a CS and stats joint major. Only the data science major is available. And so this data science major, again, is just CS and stats courses with a couple of additional requirements. I just want to emphasize, if you're interested in doing a full double major in CS and stats, this is still possible. And I know it's possible because I'm doing it. I know, so it's like, this is still an option available to you all. In terms of other relevant majors, the actuarial science, pharm, and CFM, they're all very related to statistics and analysis. And so these are extremely relevant to most data science jobs as well. And depending on what area of data science you're interested in, like there are all these other majors that are super relevant as well. So again, like combinatorics and optimization, like this is especially like operations research, and operations like various companies heavily rely on the techniques from CNO. Applied math and pure math are extremely useful for these more advanced machine learning techniques. And math finance similarly has this like analysis component that's very crucial to statistics and data science. So I just want to emphasize, overall, it's not too important precisely what major you choose. Again, you should just really be following what you're exactly interested in, but it's just a lot more relevant to choose courses that contribute to your interests and contribute to the career you want to take. And often in data science, these courses are in CS and statistics. The one thing I do want to emphasize is, as a math major, you have all the courses in the math faculty available to you. But only CS and data science majors have access to some upper year CS courses that other majors don't. So that's something you may want to consider. And the reason is the following. In the past, many people who are not in a CS major took these CS courses, which made it extremely difficult for CS majors to fulfill their requirements. And so they essentially stopped non-CS math majors from taking like third and fourth year CS courses. And so that's something to consider if you're interested in these CS courses, like they may be available to only CS majors. But with that being said, I think especially in computer science, a lot of this material is available online now, and it's available for free online. Like there's many courses on Coursera, Udacity, MIT posts free lectures. I think you can learn it yourself. And many people will say it's easier to get interviews and jobs with a CS major on your resume. And I would agree. This is like completely true. But I think you can also get these jobs with strong projects, strong past experience, and the knowledge and skills that you can gain from these free online resources. So I wouldn't stress about it too much. There's another question from Jacob here. How does the AI specialization compare to the double major or BCS and data science? Good question. So the AI specialization, in my opinion, is not well designed at the University of Waterloo for CS students. And let me explain why. The AI specialization has some of the same requirements that the data science major has, but it's a lot smaller, and they also require many engineering courses that may not be relevant to precisely what you want to do. Furthermore, a specialization on your degree does not, especially on your undergraduate degree, does not help as much as one would expect. Similarly to a minor, like a minor may show your interest in a field, but most minors only require 8 courses, and it's a very little, and so most employers don't take a huge amount of weight to that. So my suggestion to you would be to take the courses that you find are relevant to what you're interested in, and make sure you can show those skills on your resume through the projects that you do and the experiences that you have, and only do the specialization if it aligns well with what you want to do. So like for the AI specialization, I would recommend checking out exactly what courses there are, which are a mix of engineering and CS and stats. And if that really speaks to you in terms of what you think is relevant for your career, then yeah, go for it, do it. No harm in doing that. But yeah, don't be too caught up in the precise names of these minors and specializations. That's just my opinion. Oh, and in terms of comparing that to CS and stats double major, you can kind of do these simultaneously, right? Like a CS stats double major with an AI specialization is possible. I know a data science major and AI specialization is not possible because there's so much overlap, at least since the last time I checked. And so, again, it really depends. I would say like the data science major, of course, is more impactful because it's a full major versus a specialization, but I think it really depends on what courses you're interested in. Yeah, please feel free to send me an email. I'll pop that up at the end of this presentation. We can chat further about that. So Nakul has a question about BMath data science versus BCS. This is an excellent question, something I wish I put on my slides as well. So yeah, so for those of you who are not familiar, you can enter this data science major through either the math side or the CS side. And the requirements are almost identical. There's like a 2-course difference between the two. You can look at that precisely online later. But the one key difference is a BCS data science major has access to all the 3rd and 4th year CS courses. But a BMath data science major only has access to the 3rd and 4th year courses that are relevant to the data science major. And so more specifically, the BMath data science people may be able to take like the big data courses and the distributed systems courses, but they wouldn't be able to take like many other upper year CS courses, such as compilers or graphics and stuff like that. And so that's, I think, the key distinction. I don't know if that's changed. This is true as of last December, which is when I last checked. So you may want to look for more details on that, but to my understanding, that's the key difference between the two. I hope that answers the question. Cool, I guess I will continue. And so apart from the courses you can take and the majors you can choose, of course, there's great ways to get involved, like joining clubs. Like data science club is a great one, but there's like the CS club, there's the stats club, there's FARMSA, there's the AXI club, double degree club. There's various clubs, and even though they may not be directly related to data science, like it's still beneficial to join and talk to these people and to understand what they do and learn from them. And I think they're great opportunities. And also design teams, like I've mentioned, like it's a great way to meet new people, make new friends, and really learn from the people around you by joining these design teams. I like highly recommend a design team. Like as a first year, joining a design team was very helpful for me to learn about the area without, like before my co-op even, and it helped me a lot in getting my co-op as well. So again, here's some stuff. And also participating in hackathons, datathons, and recruiting events are great ways to also gain exposure and gain exposure to companies as well. So I'm sure many of you are familiar with a datathon, a hackathon, but a datathon is very similar, where you have a limited time frame and you're given some data, and you're expected to produce a full analysis with visualizations, presentations, etc. And if you follow the Data Science Club on Facebook, or if you like subscribe to be a member, not subscribe, I guess join as a member, you can be notified of these events through email. And yeah, that basically sums up my presentation for today. Thanks for listening. The deck is here, my email is here, and follow me on Twitter. I'm trying to boost up my Twitter cloud a little bit, I guess, and so you can follow me on there. And yeah, I'm happy to take any other questions you guys have for the next, I guess we have 8 minutes. Can we obtain jobs which are more CS related with a data science major? This is a great question. So yes, with some qualifications. So when I say yes, I mean, yeah, you can definitely transfer data science, be a data science major and get CS jobs, but you can get CS jobs with any math major as long as you can prove that you have these skills. So through the project that you do or the past experience that you have. So particularly projects are super critical to getting your early roles in any field. And so if you can prove that you have these CS skills through the projects that you have or the design teams you join, et cetera, you can gain CS jobs through any math major because math is like an inherently analytical and algorithmic focus and theoretical like field. And so you definitely have the cognitive ability to be like a software engineer or like a developer, but it's just a matter of proving that you have those skills. I have a question from Jacob here. How do we find a list of design teams available and what the joining process is like? Good question. So on these slides, that link, that blue design teams thing is a link. And so you can actually click that and see all the design teams, and they all have their own processes. But generally, they all hire within like the first 3 weeks of a term. And so there's tons of time to look into that. So Nicole, according to you, what would be better, majoring in data science from the math or the CS side? In my opinion, majoring from the CS side will give you access to more courses in third and fourth year. Again, I would double check this. I'm fairly confident I'm correct, but I would make sure the policy hasn't changed. But majoring from the CS side gives you access to more CS courses in third and fourth year that majoring in the math side does not give you access to. And of course, it depends totally on what you're interested in as well, right? If you don't care about these other CS courses, then it really doesn't matter at the end of the day. An employer is not going to see that you did a B math versus a BCS and make a different decision. At the end of the day, it's very not important precisely what your major was. But it just matters about what skills you gain through it and what you can demonstrate using those skills through projects and experience. How hard would it be to major in data science? That's a good question. I'm actually not 100% sure what the process is like to become a data science major. I know it is competitive because it's a small program. I believe it's more competitive than most majors in the math faculty, but I'm not sure how hard it is to declare a data science major. If you're wondering about the difficulty of actually completing the major, I think it's very comparable to the other programs in the math faculty. I wouldn't say it's any harder. It's very comparable in difficulties to stats and CS and et cetera. And of course, even if you don't major in data science, like you can also major, of course, in computer science or statistics, one of the two independently. Both of those are extremely relevant and extremely recognized in the field. And arguably, they're even more recognized because it's very difficult to understand exactly what you're learning as a data science major because it's so poorly defined. But as a CS or stats major, more companies are very familiar with it. And of course, you can also take the route that I did, which is doing the full double major, which is more challenging because you have to do the requirements of two different majors. But for me, it was very valuable because I was planning to take most of those courses anyway to like kind of learn both sides. I hope that answers the question. Anything else? Yeah, also many of the comments I'm making about things being worth it versus not worth it are definitely like my opinion. It's not really endorsed by the club or endorsed by the faculty or anything like that. This is really just from my experience and in my opinion. So yeah, I would definitely encourage you to hear out other people's thoughts and see what's worth it out there as well. Yes, a recording will be posted online. I believe Ina will post it in the freshman group, but I'll also try to get a copy of this recording to post on the data science YouTube channel as well. Lovely. We have 3 minutes left. Yeah, I'm glad you guys enjoyed. Yeah, definitely feel free to reach out via email. I'm very happy to help out, and follow me on Twitter. I tweet data science stuff. Yeah, I'm definitely clout chasing right now, so I should stop. Yeah, and I hope you guys have a good virtual first year. It's tough to have your first term be virtual, but yeah, hopefully it's great. Cool. I will end the recording now.